The U.S. Gerald R. Ford CVN-78 is the lead ship of the Gerald R. Ford class of aircraft carriers in the United States Navy. Named in honor of the 38th President of the United States, Gerald R. Ford, it was commissioned on July 22, 2017. The ship is designed to be more efficient and capable than its predecessor, the Nimitz class, and is the first new American aircraft carrier design in 40 years. In today's video, we're going to go through the works of the majestic aircraft carrier U.S. Gerald, so grab on tight and get ready. The U.S. Gerald R. Ford is the largest and most advanced aircraft carrier in the world. It is 1,106 feet long and 256 feet wide, and has a displacement of approximately 100,000 tons. It can reach speeds of over 35 knots and can accommodate a crew of 4,660, including air wing personnel. One of the major advancements of the U.S. Gerald R. Ford is its Electromagnetic Aircraft Launch System EMALS, which uses electromagnetic energy to launch aircraft from the flight deck. This system replaces the traditional steam-powered catapults used on previous aircraft carriers, and is designed to be more reliable and capable of launching a wider range of aircraft. The Electromagnetic Aircraft Launch System EMALS is a new technology that is being used to launch aircraft from aircraft carriers. It is currently being used on the U.S. Gerald R. Ford, a United States Navy aircraft carrier that was commissioned. EMALS uses electromagnetic energy to launch aircraft, rather than the traditional steam-powered catapults that have been used in the past. This new system has several advantages over the old steam-powered system. One of the main benefits of EMALS is that it is more efficient. The steam-powered catapults required a large amount of energy to launch an aircraft, and this energy had to be generated by the carrier's boilers. EMALS, on the other hand, uses electrical energy, which can be generated by the carrier's nuclear reactors. This means that the carrier can launch more aircraft with the same amount of energy. Another advantage of EMALS is that it is more precise. The steam-powered catapults were not able to launch aircraft at specific speeds or with specific amounts of force. EMALS, on the other hand, can launch aircraft at specific speeds and with specific amounts of force. This means that aircraft can be launched with the exact amount of energy they need to take off, which reduces wear and tear on the aircraft. EMALS also has a greater launch weight capacity. The steam-powered catapults were limited in the weight of aircraft they could launch, whereas EMALS can launch heavier aircraft. This means that aircraft carriers using EMALS can launch a greater variety of aircraft, including larger and heavier aircraft, such as the F-35C Joint Strike Fighter. In addition to these benefits, EMALS is also more reliable than the steam-powered catapults. The steam-powered catapults were prone to breakdowns and maintenance issues, while EMALS has fewer moving parts and requires less maintenance. The ship also features an advanced arresting Gear AEG system, which uses a series of motors and generators to slow down and stop aircraft as they land on the flight deck. The advanced arresting Gear AEG is a key component of the aircraft launch and recovery system on the U.S. Gerald R. Ford CVN-78. The first of the United States Navy's Gerald R. Ford class aircraft carriers. The AAG is responsible for slowing down and stopping aircraft as they land on the flight deck of the ship, allowing for safe and efficient operation of the carrier. The AAG system is a significant improvement over the previous arresting gear system used on Nimitz class carriers. The new system utilizes water twisters, also known as jet deflection systems, to slow down and stop aircraft as they land on the flight deck. These water twisters are located at the aft end of the flight deck and work by deflecting high-pressure water jets upward, creating a water cushion that the aircraft's tailhook can engage with to slow down and stop the aircraft. The AAG system also includes a new Electromagnetic Aircraft Launch System EMALS that replaces the traditional steam-powered launch system used on Nimitz-class carriers. The EMALS uses electromagnetic energy to launch aircraft, which is more efficient and allows for a wider range of aircraft to be launched from the carrier, including heavier and faster aircraft. One of the main advantages of the AAG system is its ability to handle a larger number of aircraft landing and launching operations. The AAG system is also more reliable and requires less maintenance than the previous arresting gear system, which translates to a more efficient and effective aircraft launch and recovery system. Additionally, the AAG system has been designed with the capability to be retrofitted onto the existing Nimitz-class carriers, which would provide a significant upgrade to the launch and recovery system on these ships. In addition to its flight deck, the USS Gerald R. Ford also has a number of other advanced features and systems. It is equipped with a new radar system, the N/Spy-3 multifunction radar, which is capable of detecting and tracking a wide range of targets. The MFR is designed to be a highly versatile and capable system, able to perform a wide range of functions including air and surface surveillance, target tracking, and missile defense. One of the key features of the N/Spy-3 MFR is its ability to perform multifunction operations. This means that it can simultaneously track multiple targets in both the air and on the surface, providing the USS Gerald R. Ford with a comprehensive view of the battlefield. Additionally, the MFR is able to detect and track low-flying aircraft and missiles, making it an important tool for missile defense. Another important feature of the N/Spy-3 MFR is its advanced electronic beam steering technology. This allows the radar to quickly and accurately track targets, even in the presence of clutter and interference. The MFR also has a high-resolution imaging mode, which enables it to provide detailed images of targets, making it easier for operators to identify and track them. The N/Spy-3 MFR also has a built-in electronic countermeasures ECM capability. This allows the radar to detect and identify electronic jamming signals and take appropriate actions to counter them. This makes the MFR a highly resilient system that is able to operate effectively in a jamming environment. The N/Spy-3 MFR is a critical component of the USS Gerald R. Ford's defense and surveillance capabilities. It provides the ship with a comprehensive view of the battlefield, allowing it to detect and track targets at long ranges. Its advanced electronic beam steering and ECM capabilities also make it a highly resilient system that is able to operate effectively in a jamming environment. The ship also has a number of defensive systems, including close-in weapon systems and chaff and flare dispensers to defend against incoming missiles. The USS Gerald R. Ford is also designed to be more efficient than previous aircraft carriers. It has a smaller crew size and uses nuclear power to generate electricity, reducing the need for refueling. The ship also has a number of systems and technologies that are designed to reduce its environmental impact, such as a sewage treatment plant and a water desalination system. One of the key ways in which the USS Gerald R. Ford is environmentally friendly is through its use of nuclear power. Unlike traditional aircraft carriers, which rely on fossil fuels to generate electricity, the USS Gerald R. Ford is powered by two nuclear reactors. These reactors provide the ship with an almost limitless supply of energy, eliminating the need for fossil fuels and the associated emissions. Additionally, nuclear power does not produce any greenhouse gases, which makes the USS Gerald R. Ford a much cleaner and more sustainable option than traditional aircraft carriers. Another way in which the USS Gerald R. Ford is environmentally friendly is through its use of advanced water treatment systems. The ship has been designed with a number of systems that are able to purify and recycle water, reducing the need for fresh water and minimizing the amount of wastewater that is produced. This not only helps to conserve resources, but also reduces the ship's impact on the environment. The USS Gerald R. Ford also features a number of other environmentally friendly technologies and design features. For example, the ship has been built using materials that are less harmful to the environment, and it has been designed to minimize the amount of waste that is produced. Additionally, the ship has been fitted with energy-efficient lighting and other systems that help to conserve energy. Despite its advanced capabilities, the USS Gerald R. Ford has experienced a number of delays and cost overruns during its development and construction. The ship was originally scheduled to be commissioned in 2014, but the date was pushed back multiple times due to technical issues and budget overruns. The total cost of the ship is estimated to be around $13 billion, making it one of the most expensive ships ever built. In conclusion, the USS Gerald R. Ford is the largest and most advanced aircraft carrier in the world. It is designed to be more efficient and capable than previous aircraft carriers, and is the first new American aircraft carrier design in 40 years. Despite its advanced capabilities, the ship has experienced a number of delays and cost overruns during its development and construction. It is a powerful asset for the United States Navy, and it is a symbol of the country's naval superiority. What do you think about the majestic aircraft carrier? Let us know in the comment section. Don't forget to like, subscribe, and smash the bell icon to stay updated on all new videos coming up.